Hello, in this lesson, we are going to discuss about related rates. So what is a related rate? You could think that before we have dy by dx, that is a slope. And sometimes the x and y are having the same unit, but related rates, they don't have the same units. So this is a different units. So one may be the volume, so it's meter cubed, and another variable may be radius, is in meters. We know the rate of change for the radius, but we want to find the volume rate of change with the time. So that is called related rates. So they don't have the same unit. So in a related rates problem, so we are given the rate of change of one quantity, and we want to find the rate of change to another quantity, but is related to that quantity. So we will be able to write a formula related these two quantities. So the steps for determining related rates, the first one is if the formula not given, we need to introduce variables. So most of the time, two, sometimes you have more, and draw a diagram if possible. After that, it is important we need to set up equation to relate the two or more variables. Then after that, we are going to do the derivative to both sides again, but this time, most of the time, is with respect to time. So in short term, we can just write WRT with respect to time. Do the derivative to time. So, or you could just write d by dt. Then, after we related the d by dt, dr dt, for example, then we are going to sub in all the given information in order to find the unknown rate of change. So there are 4 steps, and we are going to see in our example 1. So a spherical snowball is melting in such a way that its volume is decreasing at a rate 1 cubic centimeter per minute. And it asks you what rate is a radius decreasing when the radius is 5 centimeter. So we want to draw a snowball, and this is a radius. So we want to write the given information here, okay? So we are going to just use a V for the volume, R for radius. So dV by dt, the rate of change for the volume with time is 1 centimeter cubed over minutes. And another one is radius equals 5 centimeter. But this one, be careful, both of them, we are going to do the substitution at the very end. Before that, we don't sub them in, okay? Especially the radius. At what radius you are going to have the rate of change for the radius, okay? And require to find. RTF represent required to find. So it's dr dt. So that is step 1. Then step 2, what we are going to do is set up equation relate the volume with radius. So for a sphere, the volume is 403 pi r cubed. And this is step 2. Step 1, introduce variable and draw the diagram. Step 3, what we are going to do is do the derivative to both sides of our equation 1. So dV by dt equals pi over 3, 4 pi over 3, this is constant. Then do the derivative to r cubed. R cubed is degree to the front, then degree minus 1. So 3r squared. Then we could simplify it. 3 divided by 3 is 1. So we have pi 4 pi r cubed. This is our equation 2. And don't forget, r is a derivative to t, so chain rule. Don't forget dr by dt. Then step 4, we are going to sub in the given numbers. Step 4, we sub in the dv by dt is 1, r is 5, then times dr by dt. So from step 4, you will see what we have to do is just isolate dr by dt by removing the 4 pi 5 squared to other side. So you will have 100 pi 1 divide. Then you could use your calculator to find out what this one is. If it didn't ask you the wrong decimal places, you could just leave it here. So, and don't forget the unit is centimeter minutes. So you could write therefore the rate of the radius with respect to time is 1 over 100 pi centimeter per minute. So this is 4 steps. So be careful that you have to have the dr by dt on this side and dv by dt to other side. Both v and r, they are the functions of time. So this is example 1. So man starts walking north at a speed of 1.5 seconds. So we could draw the compass here. So this is north, this is south, this is west, this is east. Okay. So walk 1.5 meter per second, and starting from the same point P, and a woman walks west at a speed 2 meter per second. So west 2 meter per second. It asks you what's the rate between the distance between this man and woman. So this is a rectangle triangle, and with time it will change. So we are going to introduce a time, then the distance between this P and A will be 1.5 speed times time, 1.5 t, and for the woman is 2 speed times the time, is 2 times t, so it's PB. So now we are going to see the given information. So given information will be a man's speed is 1.5 meter per second. So we want to introduce a variable for the man is y value. So y equals, y is a distance the man walked, and x is a distance the woman walked. And s is distance between two of them. T is time. So they are the variable introduced, so dy over dt is the speed. It is 1.5 meter per second, and the dx over dt is a movement's speed, is 2 meter per second, and the distance between the two is what we want to find. The rate of change. And another information given is required to find is t equals 1 minute. So step 1, we have introduced all the variables. Step 2, we are going to set up the equation. So this is a right angle triangle, so hypotenuse s squared equals other two sides, x squared plus y squared. Then step 3, we are going to do the derivative to time to both sides, and keep it in mind that x, y, they are function of t. So s squared, we do the derivative is 2s to the exponent 1. Then remember, s is a chain rule, is a function of t. Then do the same thing to x squared. So d to x squared dt give you 2x. Then remember, x is a chain rule, is a function of t. And do the same thing to y squared is 2y, then y is a function of t. So this is our second equation. And remember that we want to solve for ds by dt. So we move the 2i's to other side by doing the division to both sides of 2i's. So we have 2 divided by 2 is 1. So x over s dx dt plus y over s dy dt. This is our third equation. Then after that, we want to sub in given information. In order to solve for s ds dt, we need to have x, y, s, dx dt, and dy dt. So the given information, we have dx dt, dy dt, but we don't have x, y, s. So we need to find x, y, s when t equals 1 minute. So only you sub in the t at the very last step. So we need to keep it as same unit. So 1 minute equals 60 seconds. So x equals the 2 times t. 2 times t give us 120 meter. And y equals 1.5 times time is 60. Is 90 meter. And the distance between them is square root x squared plus y squared equals square root 120 squared plus 90 squared. Then we are going to sub in everything to this equation. So ds dt equals x is 120 over square root. This is 14481 is 150 meter. So over 150, then dx dt is 2 plus y is 90 over 150, then times dy dt is 1.5. So we do the calculation, 150 at denominator, 240 plus 135 is 375 over 150 is roughly around 2.5 meter per second. So this is a rate. Therefore, the rate of distance between them is 2.5 meter per second. So this is how you do the related rate question. So step 1, find all the given information. Step 2, connect the variables together. Step 3, do the derivative. And step 4, sub in the given information. Remember, it's important. The time you substitute only in the last step. The middle, we just keep all the variables there. Okay. Now we are going to see example 3. A water tank is built in a shape of a circular cone with a height 5 meter and a diameter 6 meter at the top. Water is being pumped into the tank at a rate of 1.6 meter cubed per minute. So this is the volume, rate of change for the volume. It asks you find the rate at which the water level is rising. So the rate of change for the height when the water is 2 meter deep. So a circular cone on the top, the diameter is 6 meter. So it's 6 meter on the top. Then the height is 5 meter. And the variable we want to introduce is the radius and the height. Then you may wonder the radius will be 3, but unfortunately, we need to move the radius here because radius is not going to be a constant. So it's just at random time. Here is a radius, here is your height. So radius, height, they are changing. So another variable we want to introduce is time. So given information, we are going to see the volume for the water is 1.6 meter cubed per minute. And we introduce RH. L is radius, H is height. You can see it from the diagram, so we don't have to re-indicate them. And this one is kind of like the domain. R is greater than 0, less than 3, and height is greater than 0, less than 5. They are given informations. Required to find is the level change, rate of change for the height, and when the height is 2 meter. So we put 2 meter at very end to remember that you only use this 2 meter for the last step. So this is our step 1. And step 2, we are going to do the set up the equation. So set up the equation, we are going to see the volume of the water. Will be the shape of a circular cone too. So volume equals pi over 3 r squared h. So this is a circular cone volume. And after that, we are going to do the d over dt to both sides. And also there is another thing that we could connect the R and the H is you have a similar triangles. So R over 3 will be equals h over 5. So this is connected R and H together. So we could write R equals times 8 to other side, we have 3h over 5. So because we want to find dH by dt, so we want h to stay. So we are going to sub R here, we are going to have pi 3h over 5, then h over 3 is squared. So we have pi times 9h squared over 25 times h, then times 1/3. So we move this to the very end. Then we simplify it, we have 25, then 3, 9, divide, you have 3, pi h cubed. So this is volume in terms of h. Then do the derivative to both sides to equation 1. Then we are going to have dv by dt on the left side equals 3 pi over 25 is a constant. We leave it here. H cubed is 3h squared. Then remember is a chain rule. H is a function of time. So times dh dt. This is equation 2. So we want to solve for the rate of change of dh dt. So we move all the other terms to other side. So it will becomes, do the division. So this is a numerator is 9 pi h squared will becomes denominator, and 25 will becomes numerator times dv by dt. So we divided this whole thing to other side, it will be just flip it. Then this is a step 2, step 3, then step 4. We are going to sub in given information. So dh dt equals 25 9 pi h squared. So h is 2, so we sub in the 2 to h. Then dv dt is 1.6. So you do the calculation, you will have times it, you have 40 over 36 pi, simplify 10 over 9 pi. So this is a final rate of change, the rate of the height at 2 meter deep of water. The height change is 10 over 9 pi meter per minute. So this is done. So now we are going to look at the example 4, a spotlight on the ground. So on the ground, shines on a wall 10 meters away. A man 2 meters tall walks from the spotlight toward the wall at a speed of 1.2 meters per second. This is a rate of change for the distance from the spotlight to the person. It asks you how fast is his shadow on the wall decrease when he is 3 meters from the wall. So 3 meters from the wall, the person's shadow. rate of change. So in this question, we need to introduce the person is distant from the spotlight at X, and the shadow's height on the wall is H. So we are going to see the given information is from the spotlight to the wall, SW is 10 meters. And the person's speed, so we are going to introduce X as a person's distance from the spotlight. Then dx over dt is constant, 1.2 meter per second is a person's speed. And a person's height is 2 meters. So the person's height is 2 meters. We are going to use from A to B is 2 meters. Then this is C to D. So H represent from C to D. These are the information given, then required to find. It's dH over dt when the person is 3 meters from the wall, so X is now 3 meters, 10 minus 3 give you 7 meters. So walked 7 meters. To the wall. So now we are going to see how to connect the dx over dt with dh over dt. X and h, you will see you have a similar triangle. So this is 2 meters, won't change. This is h, this is x, and this is a 10. So you have S, BA, and CD. So triangle SAB is similar to triangle SCD. So here be careful, the order matters. So angle S equals angle S, angle A equals angle C because it's parallel. So both of them are vertical, and angle B equals angle D. So this is angle similarity. Then we are going to have S first two letters over first two letters, SA or SC. The ratios are equal. AB over CD, last two letters over last two letters. Represent the side AB over CD, and the first last corresponding to SB and SD side. Similar triangles, they should be equal. Then we sub in the given information. SA, SD, nothing given, we just leave it there. AB is 2, CD is H, SB is X, SD is 10. So the final answer asks us for dH over dt, so we want to write X equals what? So we move the 10 to other side, times it, we have 20 over H. This is our equation 1. This is an equation that's set up between the X and H. So after that, we are going to step 3, do the derivative to both sides. So this is step 2. Step 1 is given information and draw the diagram. So d by dt to both sides. In equation 1. So we are going to see the left side is 20 over H. you could think is 20 h negative 1. So bring the negative 1 to the front, then degree negative 1 minus 1 give you negative 2. And don't forget chain rule. H is a function of t, so dh dt equals right side dx over dt. Then we solve the dh dt by moving the front to other side, do the division. So dx dt, then negative 20 h negative 2. Then continue dh dt. The h negative 2 flip it will be positive h squared over negative 20 dx dt. Then we are going to do the step 4. Subbing given information dh dt equals the h is we need to solve it. H is x equals 7, then 20 over h equals 7. We solve for h give us 20 over 7. Then we sub in 20 over 7 bracket squared negative 20, then dx dt give us is 1.2. Then do the calculation, you will have the final answer. The final answer, you will have negative 24 over 49 meter per second. So that is, therefore, the shadow, the height of the shadow is decreasing at 24 over 49 meter per second. So that is all for today's lesson. And what we have done is we do the related rays. So step 1 is draw the diagram, finding the given information. Then step 2, do the set up an equation, connect the variables together. You have dh dt given dx dt, so we want to connect h and t together. And after that, do the derivative to both sides with respect to time. Then remember h and t both are functions for time, so you need to do the chain rule. Then subbing given information, if x given h not given, use a formula that you got in step 2 to find the h. Then sub in the h, x and dx dt to find the dh dt. So thanks for watching.